Hello and welcome to Module 3 in our Django series. Today we're going to set up the models for our app. We start with a discussion on the database setup. We know by default Django uses SQLite, and you know that SQLite comes with the Python installation as well. But Django does provide support for other DBMS like PostgreSQL, Oracle, MySQL, and in the real world environment, you will use one of these. If you're using PostgreSQL, Oracle, MySQL, you need to set up the bindings like user, password, host before creating the models. Now, if you're using SQLite as we are, how is the database going to be stored? The database is going to be stored as a file on your disk. What is going to be the path to the file? That's going to be the absolute path, including the file name. Remember that when using SQLite, Django automatically creates the database. Now let's talk about legacy databases. If you already have existing databases and you want to use Django with them, what do you do? So first of all, you need to set the database setting in the settings.py file. Now is the right time to go to the command prompt . Change directory to your virtual environment. Activate the environment. And then start Visual Studio Code from here. And come straight to the settings.py file. If you look at databases, it has already been set to work with SQLite, right? Now, if, for example, you're using Oracle, then you need to put in settings like these, right? So the engine, the name of your database, and the name should be already in the tnsnames.ora file. User, password, host, and port, you can leave as blank if you're using the service name to connect to Oracle. However, if you're using the SID or the site identifier, then host and port need to be filled in. Right. Now, what about the models for these legacy databases? How are they created? Django has a utility called inspectdb. How does inspectdb work? Well, first it will introspect the database pointed to by the name setting, and then it will automatically create the models, outputting the models file to the standard output, that is to your screen, of course. You can use Unix redirection to output the file to your app models.py file, simply by doing something like this. Now let's look at the inspectdb utility in a little more detail. So the inspectdb utility creates a model for each table within the database. Now, what if a columns type cannot be mapped to a model field type? What inspectdb does then, it uses the text field and will indicate as such. Another question would be, what if your column name is a Python keyword or a reserved word? Then inspectdb will append underscore field to that field name or the attribute name. Remember though that inspectdb creates models that are not managed, which means that Django will not manage the life cycle of the model in terms of updation, etc. So this is pretty neat. I hope you will agree. This utility that allows us to directly create models from our legacy or existing databases. Now let's talk about models. What is a model? And the Django documentation states that a model is a single definitive source of information about data. Keywords here are single and definitive. Data should not reside in more than one place. Django follows the DRY or do not repeat yourself principle, which means redundancy is not good. Normalization of data is important. Now, if you're not sure about what normalization means, there is a separate video I've done on normalization, and you can find the link to that video in the description of this video. Talking about models themselves, they are essentially Python classes. Okay, so you would have a model represented like this, with statement 1 to n being the field names. Remember that these classes are subclasses of the Django.db.models.model class. In fact, it is required to be specified as such when we create our models. Now, each model maps to one table in the database. Right? Now we will discuss field types. We'll go ahead then and create our models. We learn how to activate the models. We'll talk about the machine readable name and the human readable name. Remember that once models are created, what we get is an automatically generated database access API, right, which we will work with in the next session. But coming now to model field types, we've got the auto field, and this automatically increments, right? So this can be used as a primary key, for example. It's a numeric field. Then we have character fields, right? I'm sure you know what character fields are, representing strings. We have the date field, which is an instance of the Python datetime.date class. We have a date time field, which is an instance of the Python datetime.datetime class. And then we have an email field that checks if the value is a valid email address. And then we have an integer field with the boundaries as mentioned on screen. And then we have a text field. Important to note that there are certain fields that have required arguments. For example, with the char field, you need to specify the maximum length. Now, before we get down to creating our models, let's look at the models that we're going to have in our app. We're going to have student, teacher, and grade section. The student table is going to have student ID as the first field, student name, student date of birth, address, telephone number, email ID. Teacher table is going to have the teacher ID, teacher name, address, telephone number, email ID, and qualification, or you can call it background. And this is where we will use the text field. We then have the grade section table where we'll have the year ID, and then we have current student number and max permitted students. Now we need to create relationships between these tables so that we can query them. Let's take the student table and the teacher table first. The question we will ask is, will a student have many teachers, or will a teacher have many students? And this is where business rules come into play. We are going to say here that the teacher is going to have many students. And so we'll put the teacher ID into the student table. And that's how we'll relate these two tables. Now we'll talk about the student table and the grade section table. Again, we'll ask, will a student have many years and sections, or will 1 year and section have many students? And here the answer is obvious, right? 1 year and section will have many students. And so again, year ID, that's year plus section, will go into the student table. So we've related now the student table and the grade section table. Now let's talk about the teacher table and the grade section table. And here you can think of a teacher being in charge of many students within the grade or within the year and section. And therefore, we will put the teacher ID into the grade section table. So I hope that's clear. Now, having defined the models that we want to create, let's go ahead and create the models. To do that, we need to go to our models.py file, right? So come to your models.py file. So class, and we'll start with teacher. We need to specify models.model. Remember, this is a subclass of the Django.db.models.model class. And now we can go ahead and specify the fields or the attributes. So we start with teacher ID equal to models dot, this is going to be a character field. So char field. And here we're going to put in that human readable name. So this is what will appear on screen. And then we put in a comma. And we need to specify the max length. Remember, this is a char field and max length, the argument is required. Max length equal to, let's keep it at 6. We specify this is going to be the primary key. So primary key equal to true. Then we need to specify a default and we'll put it as null, right? We come to teacher name equal to, again, models.char field. The next field we have is the teacher telephone number. So teacher telephone equal to models dot, here we'll have char field again. We have teacher email equal to models dot email field, right? No max length is required as well. We move on to the next field, which is teacher background. I'm going to call that equal to models dot text field. That completes the definition of the teacher model. Let's move on to the next model, which is going to be grade section. Again, this is a subclass of models.model, right? And here we have our fields. We'll have grade section ID. The next field is going to be current student count. That's going to be models dot integer field. And the default here is going to be 0. And finally, we have max students permitted equal to models dot integer field again. And here the default is going to be equal to 30. So we will keep reducing this value every time we admit a student. The next is going to be our student model. So class student, right? And again, it's a subclass of models.model. And here we'll have, now you can use other arguments. For example, here I'm going to use max length equal to, let's say 254, and we're also going to use unique equal to true and blank equal to true as well. Okay, so it can be that the student does not have an email ID. Okay, right, now to put in the foreign keys, we start with the foreign keys for the student model. And we have teacher ID, that first foreign key, equal to models.foreign key. And you need to specify the model related to teacher ID, which is teacher, of course. And then we need to specify what to do on deletion. So on delete equal to models dot, we're going to say restrict here. So what will happen is if we try to delete a teacher object, right, then the deletion will be stopped by this restrict option that we have chosen, right? So we are saying because teacher is referenced in student, we cannot delete the teacher, right? Remember, the teacher is in charge of students. So unless the students are gone, the teacher cannot be deleted. And that's the logic. And the next foreign key is our grade section foreign key. So grade section equal to models.foreign key again. Again, we specify the model this is coming from, and that's going to be grade section. And we need to specify what happens on deletion. So on delete equal to models.restrict again. More about the restrict option of on delete in the next session when we work with the API, right? Let's move on to the table grade section where we need to put in teacher ID, right? So here we'll just call that teacher equal to models dot foreign key, and of course that's related to the teacher model, and on delete equal to models dot, here we are using protect. Okay, I'm not going to go into what is the difference between protect and restrict. The difference will become clearer when we work with the API. Now that we've created our models, Django will use this code to create the database schema, and it will also give us the automatic database access API, which we will work with in the next session. But what's the next step? The next step is to activate the models. To activate the models, we need to tell our project that the app is installed. To do that, come to your settings.py file. Within the settings.py file, if you scroll up, you will see the installed apps. And you can see Django has already installed these apps as part of the framework, right? We need to include our app here, but for that, we need to know our app configuration class name. Where do we get that from? Come to your apps.py file. That's the name, school app config. So we just copy that school app config, just Control C on that. And then come back to your settings.py file. And here we'll just put in the app name dot apps dot and the configuration class name. Don't forget to put in a comma there, or you will end up with errors. Now that we've informed our project that the app is installed, what's the next step? The next step is to run make migrations. So come back to your command prompt. Make sure you are in the container folder, and then type in py manage.py make migrations and the name of the app. Press enter, and you can see Django has put these migrations within the migrations folder, and that's the name of the migrations file. Migrations will be created every time you make changes to models, and these migrations serve as version control for the app. They therefore shipped along with the app, right? Now, the make migrations command, what does it do? The make migrations command tells Django about the changes made to the models. Okay, and as we saw on screen, the migrations are stored in these files within the migrations folder. Now, the next thing we need to talk about is the sqlmigrate command. This will just print SQL statements on screen. This is useful, of course, to hand over to your database administrators who may want to know what changes Django is going to make to the database structure. So let's now go back to the command prompt and type in py manage.py sqlmigrate. We need to put in the name of the app and the migration number. So 0001, press enter, and you see all those create table statements on screen. Right, so as I said earlier, these statements, as you can see, are SQL statements, and they are useful for database administrators who may want to read SQL scripts, right? Remember that sqlmigrate does not run migrations on the database, right? These are just recommendations for the changes that are going to be made. The migrate command will actually apply the migrations to the database and register the changes, right? So now we need to go back to the command prompt. I'm going to clear the screen and we'll type in py manage.py migrate. So now you can see that Django has not only created the tables for our app, right, applying those migrations, but has also created other tables. Now we can see all these tables. To see them, we need to use dbshell. To use dbshell, we need to download sqlite.exe, right? So to do that, go to your browser and just type in SQLite download. Okay, there's no need to type in that URL. If you just say SQLite download, click on the SQLite download page. If you scroll down, you will see the binaries for Windows. And we need the command line tools. So we'll click on this file. And here, of course, I'm getting a warning, but I'm going to ask for it to be kept. And you click on show more, keep anyway. And now you can open the file. And if you click on this folder, you see these 3 files, right? So these 3 files, you can copy them all into C drive, and then the users folder, your username, and then your virtual environment folder and the container folder, right? So you can just paste those there. Okay, and close this window now. Come back to your command prompt. And now what we'll do is we'll just type in py manage.py dbshell. Now we have the SQLite prompt. Type in .tables and you see the tables that were created. So .exit to exit this prompt. Moving on. How does migrate work? So what happens is migrate looks at the installed apps, will look at the migrations, and then will create or modify the tables, right? Remember that every time we make model changes, once we change the models in our code, that is in models.py, we then need to run make migrations, which will create migrations for the changes. And after that, we need to run migrate, which will apply the changes to the database. So every time we make changes to the model, we need to run both make migrations and migrate mandatorily. Coming to machine readable name versus human readable name, we've already done this. Machine readable name, remember, is the field name used in our code. So if we come back to our models.py file, what you see on the left here, these are all the machine readable name. And then of course, this is the human readable name. This name will also be used by the database as a table column name. That's the machine readable name again we're talking about. The human readable name is optional. If used, it is to be the first position and argument in the field definition. Human readable names are for documentation purposes. If they're not used, then Django will use the machine readable name, right? This ends module 3. In the next session, we will work with the database access API, as I said earlier. Till then, take care. Bye.